Insolar platform's very high scaling performance is due in large part to its high-performance architecture. Insolar uses a separation of concerns approach where different nodes have different roles to play. The first type of nodes are compute nodes. These are the CPUs of the system. They are virtual and can be either executors, that is to say the virtual machines that execute the smart contracts, or validators, that is to say the virtual machines that make sure that the executors did their job properly. They are both allocated their roles randomly during every pulse of the network. The pulse of the network is the heartbeat that allows work to be coordinated. It defines the order of events, communicates network status and node health and capabilities, and broadcasts a distinctive randomization coefficient. We use a one executor, multiple validators model, which means that massive amounts of discrete and independent smart contracts can be executed in parallel in the same pulse of the network, and the consensus effort can be adjustable. The other two types of nodes are part of the ledger system. The first of these are throughput nodes. Throughput nodes are the cache of the system. They're used for block building and validation. They collect the state of a smart contract, which is the output the smart contract generates when they're executed. They build mini blockchains of that object, which they persist over time. They store the data that needs to be used very often in a very fast short-term memory. During every pulse of the network, these objects get assembled and blocked together in a cross-chaining configuration to a storage blockchain that are stored on storage nodes. Storage nodes are used for long-term storage and retrieval of blocks. This separation of concerns architecture has a profound effect on the scaling capabilities and the cost dynamics of an Insolar network. Node types can be scaled independently, and in both vertical dimensions, adding bigger and faster nodes, and in the horizontal dimension, adding more of a type of node. To further improve throughput and optimize efficiency of the platform, Insolar supports an observer. This mechanism is extremely useful in read-only use cases and allows for much faster user experiences than raw ledger access would. It combines replication technology with rational database technology and is accessible via an API to allow for an extremely high-performance access to high-volume read-only information. The net effect of all of this is that the network can be tuned and optimized to a particular type of workload. It can be also very adaptive to a changing workload need. Another implication of this is the impact on the economics of providing network resources. The separation of concerns architectures allows for high degrees of specialization of hardware infrastructure so that providers can sell and price node support that is optimized to perform various different tasks. This will serve to further optimize the price performance of the network. So, Insolar networks are not only highly scalable and extremely cost efficient, they can be continuously right-sized, making it a compelling platform for production scale deployments and variable workloads that improve business freedom of action and future-proof investments.